Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at the stationary points or the turning points of the curve. Example 1 says, find the stationary or turning points. So we need to find the stationary points of this curve and distinguish between them. So let us first find the stationary points and then we distinguish between them. How do we distinguish between them? We tell whether the point is a maximum point, is a point of inflection, or is a minimum point. So, at A, the curve is given by y equals to 2x cubed minus 6x plus 2. This is the curve. So, we need to investigate the turning points of this curve and then we tell whether the point is maximum, minimum, or the point of inflection. Remember what I said before in the introduction is that at any stationary point, okay, dy dx is 0. At any stationary or turning point, they are the same term, dy dx is 0. Okay, so that means we need to get the derivative of the curve. After getting the derivative of the curve, we say at the turning point, dy dx is 0. And in that manner, we shall be in position to get the turning point. So let us differentiate the function of the curve. Therefore, dy dx will mark us a field equals to, let us differentiate this. We shall get 6 x squared minus 6. Okay, that is the gradient function of the curve. Okay, this is the gradient function of the curve. But we are saying that at any turning point, dy dx is 0. But dy dx equals to 0. That means you can substitute for dy dx as 0 at the turning point so that we get the values of x at the turning point. Therefore, 0 equals to 6x squared minus 6. Now, let us make x the subject of the formula. So, I can carry 6 this side so that it becomes positive 6 equals to 6x squared. Both sides by 6, both sides by 6. Therefore, x squared equals to 1. Then you take the square root on both sides. Therefore, x equals to plus or minus 1. And we know that. So, the two values of x are, the first value of x is 1, positive, and the second value of x is negative 1. So, these are the two values of x at the turning point. What does it mean? It means that here we have two turning points. So we have two values of x. We have two turning points. Or if we had three values of x, it would mean that we have three values. We have three turning points. So this question here, this curve here has only two turning points. So let's see whether the 2 points are minimum, maximum, or point of inflection, any two. Now from here, we have two values of x. But remember, a turning point is a coordinate. Okay, it is a coordinate point. That means it must have the value of x and the corresponding value of y. So let us use the two values of x to get the corresponding values of y. So for x equals to 1, what is the value of y? We simply come back and substitute in the equation of the curve. So that we now have y equals to 2, x is 1, power 3, minus 6 times 1 plus 2. We are using the first value of x to get the corresponding value of y, such that it is the coordinate point. So from here, we find y. 2 minus 6 plus 2 negative 2. Yes, negative 2. So the point here, first point here becomes 1 and negative 2. That is how you tell the coordinates of a point. Okay, we have used the first value of x to get the corresponding value of y, and that is one turning point, which we don't know whether it is a maximum turning point, it is a minimum turning point, or it is a point of inflection. We don't know yet, but let's keep that point. We are first identifying the point. Now, what if x is negative 1? We also can say for x equals to negative 1. What is the corresponding value of y? You come and substitute again. Y equals to 2. X now is negative 1, but cube minus 6 times negative 1 plus 2. So we shall have negative 2 plus 6 plus 2. I'm getting 6 here because it even becomes negative, positive. I'm getting 6 here. So when x is negative 1, the corresponding value of y is 6. Okay? The corresponding value of y is 6. That means the next point is negative 1 and 6. Now we have two turning points. So we have identified the two turning points. After getting the two turning points, the question says that we need to distinguish them. That means we need to tell, is this point a minimum point, a maximum point, or a point of inflection? Is this point a minimum point, a maximum point, or a point of inflection? We need to tell. Now, for us to distinguish them, remember we said that there are two methods. One, we can test for the slope before and after a point. Two, we can find the second derivative of the curve. So we are using the method of second derivative. I'm not going to do the other method. I will use only the one for second derivative. That is d squared y dx squared. Now, how do we get the second derivative? We say you come and use the gradient function of the curve, which is dy dx is 6x squared minus 6. For you to get the second derivative, we use the first derivative. Okay, this is the first derivative. What do? We differentiate. Okay, we differentiate the first derivative again. In other words, for us to get the second derivative, we differentiate the equation of the curve 2 times. Okay, we differentiate it 2 times. That means I don't want to go into context of how d squared y dx squared comes about, but a small light of it is that we differentiate this again. That means I'm differentiating with respect to x. Okay, the function, I'm starting with the left hand side, dy dx equals to, I'm also differentiating with respect to x, the right hand side, which has 6 x squared minus 6. Okay, we opened this bracket, d times d is d squared, then y over dx times dx, it gives us dx squared. Dx is a single term. It is a single term. Don't think that dx times dx becomes d squared, x squared. No. Okay? Dx is a single term. So dx times dx means dx squared. So this squared is for that single term. Equals to, then we come and differentiate the right hand side of the equation, this side. So that we have 12x, only 12x. Okay? So this is the second derivative. Now, always don't waste your time doing what I've just done here. No, I was showing you how d squared y dx squared comes about. But what you need to do, just state the first derivative, then just say d squared y dx squared equals to, then you differentiate this side straight away. Here we need all of x. Okay? So after getting the second derivative, okay? After getting the second derivative, now we need to test for the points. So I'm going to start testing for this point, for the first point, but you can choose any. So let me start with point 1 and negative 2. Remember, this is the value of x, this is the value of y. This one was the value of x, 1, y was the value of negative 2 was the value of y. So in the second derivative, we substitute for x, so that we say dy, so that we say d squared y dx squared equals to, then we substitute for x in this expression, so that we have 12, our x is 1. 1 times 12 is 12, okay? Now, check, is that number more than 0? Is it equal to 0 or it is less than 0? 12 is more than 0, okay? And we said before that if d squared y dx squared is more than 0, okay? If it is more than 0, then this point is what? Is the minimum turning point. It is a minimum turning point. If it is more than 0, it is a minimum turning point, not maximum. If it is more than 0, it is a minimum turning point. Okay? So, because d squared y dx squared is more than 0, it makes this point now a minimum turning point. Therefore, the point 1 and negative 2 is a minimum turning point, or it is a minimum stationary point. That is, we have identified the point and we have stated what it is. That is 1. Let us go to the next point. The second point that we have got there is negative 1 and 6. Negative 1 and 6. Let us see whether it is a minimum point, it is a maximum point, or it is a point of inflection. But because here we have got one point as a minimum point, we don't expect this again to be a minimum point. No. It's either going to be a maximum point or a point of inflection. Now from here, what do we do? We have already differentiated. Okay, we already have the second derivative. So what we just need to do is use the second derivative to test for the points. So I've used it, I've tested for the first point. I'm going to use it and test for the second point. So this is my x, this is my y. So d squared y, x squared equals to 12 x. What is my x in this case? My x is negative 1. Therefore, 12 times negative 1 is negative 12. Now, let us judge. Okay? Is negative 12 more than 0? Is it equal to 0 or it is less than 0? Negative 12 is less than 0. And we said before that if d squared y dx squared is less than 0, we say that if the second derivative is less than 0, then the point is a maximum turning point. Maximum turning point. Don't confuse. If the second derivative after substituting for x is less than 0, it is a maximum turning point. Therefore, the point -1, this is the point 6, -1, 6 is a maximum turning point. Is a maximum turning point. Okay, is a maximum turning point. So this is how you get the turning points, and that is how we distinguish them. That is how we tell whether the point is maximum, minimum, or a point of inflection. This is just example 1, part A. By the time we go to example 5, you will be a pro. Don't worry. Thank you.